Welcome, everyone. My name is Adam Wildavsky. I'm a software engineer here at Google Zurich. Come on in, we haven't started yet. And I have no idea what the fire marshals say about this room, so just come on in, bring a chair.
We run for the hills down that door.
Yeah, hey, we're right by the fire exit. What could be the problem? Famous last words. So I am very happy to introduce Dr. Fred Singer. He happened to be in Zurich, and I happened to find out about it in time to invite him here. And I'm not going to go over Fred's bio. I sent you all the Wikipedia link, and there's plenty more you can find out. But Fred has had a long and distinguished career in a number of areas in science, and he can tell you more about that than I can. So, Dr. Singer. Oh, and there will be plenty of time for questions. I'll take some from the floor and some from the dory, and we're scheduled to end at 5, but if anybody wants to stay longer, I have no place to go, and Dr. Singer has graciously agreed to stay for dinner here at Google. So.
This is Thursday. I think I'm in Switzerland, right? Grüezi alle miteinander. I will speak in my international English using short sentences. If anyone has trouble hearing me, raise your hand. I'm delighted to be here. It's a kind of a pickup appearance. I was invited to a conference in Ipcc, Sicily, which took place last week, where I just left yesterday, and spoke there. And I thought, as long as I'm in Europe, I should visit other places. I am invited to speak at the University of Hamburg, then in Holland, then in Brussels, then in London at Imperial College, and then in France. I'm in Zurich because I had an interview this morning, but I'm delighted by your turnout here and hope to get some very good, challenging questions. I'm ready to proceed in any way you like. I will turn to my friend Adam and ask him to put questions to me if you have them, or if not, I will just give my brief introduction and then let you ask any questions you like.
I'd say let's go for a 5 or 10 minute introduction, and then we have enough questions to keep us busy. I showed you one question in advance. You said you could take an hour answering just that one. So
Yeah.
We'll try and do just a couple minutes per question.
I will spend about 5 minutes or so as an introduction. I'm a physicist. I'm a professor at the University of Virginia. I don't teach anymore. I run a project called the Science and Environmental Policy Project, which tries to apply scientific principles and knowledge to important environmental issues. We've looked at different issues that appeal to me personally as an atmospheric physicist. So we've looked at acid rain, we've looked at stratospheric ozone, got sidetracked into looking at radon and asbestos, although I don't claim to know much about health effects, but ended up spending most of our time on the issue of climate change, which happens to be close to my general specialty of atmospheric physics. Climate change is a challenging and interesting problem, and it is challenging because it has not only scientific ramifications, but policy ramifications, economic ramifications. It has involved the nations of the world, and by close estimate, some hundreds of billions of dollars have been spent on this issue. In my estimation, uselessly, wasted. This money should have been better spent on helping the poor in the world achieve a better living standard, a better environmental quality for drinking water, for food, and so on. Instead, has been wasted in a variety of issues that I hope we can touch on in the question period. I thought I would confine my introductory remark purely to the science and leave the policy and economic issues to questions. The basic issue in the science is very simple. We know that climate changes all the time. It's been changing for millions of years, probably billions of years. We have some knowledge of past climate change. We have more detailed knowledge of climate change in the last 100 years, thanks to thermometers, and in the last 30 years, thanks to satellites carrying radiation instruments. So we're looking at a very small slice of the history, of the climate history of the planet Earth. And we're trying to figure out this fundamental question, which is how much of this climate change is natural and how much of this is man-made. The word is anthropogenic. It's a long word. Anthropogenic. Both effects are plausible. In other words, we know that climate change has always taken place on a natural basis. And there's no reason to think that these natural causes, whatever they are, have suddenly stopped just because we are producing carbon dioxide through the burning of fossil fuels. So natural change is certainly plausible. But, on the other hand, we know that human activities, burning of coal, oil, and gas, has increased the carbon dioxide content of the atmosphere. At least most people think so. There are some dissenters, obviously. Always dissenters. So, and we know that carbon dioxide is what's called a greenhouse gas. That means it absorbs infrared radiation based on laboratory measurements. There's no question about that. So one would expect that the increase in carbon dioxide would have noticeable climate effects. It's plausible. How can you decide, if you look at a thermometer and you see the temperature going up, let's say over a period of 20 or 30 years, how can you tell whether the cause is natural or man-made? How would you tell? Supposing I hand you a record of temperature change and say, okay, here's how the temperature has changed in the world in the last 30 years. Tell me, is it natural or is it man-made? It's a very difficult issue. One has to look at some detailed evidence. In the discussions that have taken place, it has been generally agreed that there's only one methodology that works. That is to compare so-called climate models that use an increase in carbon dioxide as a driver, use the predictions of these models, and check them against observations. Obviously, the models predict the future. We don't know what the observations of the future will be. So what one does is to look, pretend that the climate model starts, let's say, in 1980, 30 years ago, and compare the results of these model calculations with the observations of the last 30 years, taking account that the observations are never perfect, always uncertainties, and there are uncertainties in the models. Well, it turns out that this has been done. And guess what the results are? The models do not agree with the observations. Now it's interesting, and this is an interesting political point. Both the models and the observations that I will show you come from the same source, the so-called Ipcc, in French, GIEC. it's the science panel, the Klimaatraad, Wissenschaftsrat, whatever it's called, of the United Nations. So, using their models and their observations, we can do a comparison. So I'll quickly show you what that looks like. Does this have a pointer on it?
Oh, a pointer.
A laser pointer or something like that?
I don't think we have a laser pointer. Anybody know otherwise?
You can use the mouse on the screen.
Yeah, I get right. They can see your mouse pointer on the screen. That'll work well. And anything you see here, the audience sees.
Okay. Oops. This moves very fast.
I could slow it down for you if you want. Let me know.
Yeah, probably. Well, yes.
Hold on. Tech break. System preferences. What is it? Mouse or keyboard and mouse? There it is. Mouse. Tracking speed from way fast to much slower.
Fantastic.
All right.
Scrolling speed.
Scrolling speed also slower.
Okay.
Okay.
I now have a slow mouse. First of all, I will try to pick out the results of the models. Yeah, it works. As you see, it comes from an official report. I've added nothing to this. I need to orient you. Here is the equator. Here's the North Pole. Here's the South Pole. This is altitude. The colors indicate the temperature trend over the last, 50 years. Okay. It shows that the temperature trend has a maximum in the upper troposphere. That's about 10 kilometers altitude over the tropical region. This is the result of every climate model. The Ipcc has kindly collected these data and presents them in this graph. So now this is what we have to compare with observations. How do you observe temperature trends in the troposphere? The answer is with radio sondes carried in balloons at weather stations. There's some 100 or so stations in the world that have radio sondes that regularly measure temperature as a function of altitude, and they've been measured now since 1958, which is the reason why this starts in 58. So we have the measurements. There may be some problems with them, but those are small technical problems. So let's look at the measurements. Let's see. Here we are. No hot spot. In fact, you get a cool spot. In other words, the observations disagree completely with the results of the models. Now, the funny thing is, in this report, they admit this. But in the summary of the report, they say, well, there must be something wrong with the observations. Of course, we don't believe that. So what we've done is to publish a paper shown here, which lays it all out. This is our paper, published in 2007. We've published since then, but this is it. It shows that the trend, here's trend. Trend is measured in degrees per decade. And here's the altitude, measured as pressure or as altitude in kilometers. Kilometers might be easier for you. You'll see that the models show an increasing trend, which peaks at around 10 kilometers. Yeah. These show the error bands for the models. some dispute about that also. Lots of disputes. And here are some of the observations analyzed by different groups. A group in the United States by NOAA, and a group in England at the Hadley Center, and a group in Germany. So they all show a decreasing trend. So the models show an increasing trend, the observations show a decreasing trend. End of story? Not quite. Obviously, this result has created a lot of consternation among the alarmists, the global warming alarmists in the United Nations. And they have been feverishly trying to do something about the fact that this disagreement has now been published in the open literature. If you read the ClimateGate email, have you all heard about ClimateGate? Okay. If you read the emails, you'll see the consternation on saying, how could this paper have been published in a recognized journal? We should have stopped it. Well, they've stopped other papers. They managed not to stop this one. However, they've tried to respond to it in some way. It's interesting how they responded. They manufactured a new data set that shows, first of all, an increase with altitude, and then they expanded the error bars to cover all of the data. Obviously, if you have error bars wide enough, you can explain anything. So now we're responding to this and showing that they've made errors, statistical errors, other errors, and we try to get it published. It's been turned down already by 2 journals. That's one of the problems, which I hope we can discuss later, that it's becoming increasingly difficult to publish scientific work that contradicts the accepted wisdom of the United Nations panel. All right, that's just point number 1. In point number 1, I have simply used the IPCC's models and observations. Now I will show you point number 2, where I examine closely the IPCC models. And this is my exhibit number 2. What do all these squiggles mean? Well, let me explain. Modelers, when they run a model, if they're careful, they will run it more than once. They'll run it a second time without changing the model in any way. They simply run it again. Why do they do that? Because they get a different result. So they average the 2 and publish the average. Normally, the modelers will not tell you the results of each run. Normally. One exception, the Japanese. Bless them. The Japanese climate model uses 5 runs, and they have published in the open literature the result of each of the runs. Number 1, 2, 3, 4, and 5. And if you look closely, you will see that each run gets a different trend. This first run gets a trend of 0.042 degrees per decade. The second run gets a trend which is almost 10 times as large, and anything in between. So not only are the trends different, but they're different by a large factor. And this has now been published. So my question to you is...
I'm sorry, did you say it has now been published or has not been?
It has been published.
Okay.
I've simply reproduced it here. My question is, which of these trends then should one compare with the observed trend? 1, 2, 3, 4, 5, or none of the above? The right answer is none of the above. Because if you run another run, you'll get a different result again. This is a consequence of the chaotic character of nonlinear partial differential equations. The climate models use nonlinear partial differential equations, fluid dynamics and other things are involved in this. And one of the properties of these nonlinear partial differential equations is that they are chaotic, which means that the result depends on the initial conditions. And you never get the same initial conditions if you do a second run, always slight differences. So, we have done a study, which we hope to publish. It's been sent in. So far, it has not been turned down. It's been sent to a journal in Germany, which is the other guys may not have heard of yet. It's a matter of finding an editor who has an open mind and is willing to send it out for review. So our result shows, here it is, that you have to run a model. Let's look at the blue one. At least 10 times before the asymptotic value is reached. In other words, if you take a cumulative average of these trends, you have to run at least 10 of these before the cumulative average settles down to an asymptotic value. That's what we find. Before that, it jumps around a lot. This is for 40-year runs. For 20-year runs, that are shorter runs, you even have to do 20 runs before you reach an asymptotic value. Okay. Why is this important? Well, it's important because none of the Ipcc models has more than 5 runs. Most of them have only 1 or 2. That's what they publish. The result of 1 run, which is meaningless, just meaningless. And then they average all the runs together, giving equal weight to the single run models and the multi-run models, which makes no sense either. Obviously, the multi-run models must be more reliable than the single run models. Well, that's all I want to say about Ipcc models. Now let me talk about Ipcc data. That's the last item.
I'm sorry, did you have a question?
Yeah, how long does it take to do one of these runs?
Quite a long time, and that's why they don't do many runs. They're expensive. It takes time and expense. And modelers would rather play with new ideas in modeling than do the same run over and over again. But they must do that if they want to produce a reliable result.
Excuse me.
Now,
I'm sorry, we have a question in the
Quick
back?
one.
question?
You say it takes a long time. How long? What dimension?
Can't hear.
How long? You said it takes a long time to run the model.
Depends on the model. It depends on the speed of the computer. I don't know these answers.
Days, months. What are you talking about?
I don't know these answers, but we can discuss that later.
But who ran the models for you?
I'm trying to.
Oh, can I help?
No, it's all right. I think I have it.
Okay.
Yeah. Can you all see the top curve? It shows global temperature over the last 100 years. Just look at the red curve. This is the standard view of how global temperature has changed in the last 100 years, which I will now critique. You will see 2 large increases, one between 1910 and 1940. This increase is genuine. By genuine, I mean it is reliable, it is seen in other kinds of data. You'll see another reported increase between 1979 and 2000. This increase is fake. It does not exist, in my view. It is only seen in the surface data taken from weather stations. Now, we've had doubts about that for some years. But, you cannot really make these statements. People will say you're crazy. But since ClimateGate, since we know that these people have been manipulating the results from weather stations in some way, it has become less hazardous to attack such results. So what I've done...
Sorry, are you saying people are... Which people are manipulating...
I can't hear.
Which people are manipulating data from weather stations?
We have no evidence that they actually manipulated the data, but I will show you some possibilities of how one can easily do this.
So,
remind me to come back to that.
So you're saying they did not, that nobody is manipulating data?
I will.
Because I thought you said that people were definitely manipulating data from weather stations.
Oh, I'll come to this right now. One way in which you can show a warming without it really taking place is by going you see, now I've lost my way.
Yeah, you want
Well,
slide deck
anyway.
again? The slide sorter?
I go back to the slide sorter, yes.
Yeah. There we go.
Okay, I think I'll be able to find it now. We have found 6 different pieces of evidence against this warming. I will quickly list them, or list some of them. Some are very technical, which I will not go into, but some are fairly obvious, easy to understand. First of all, the atmospheric data don't show any warming. Because during the same period, while the surface is said to be warming, the atmosphere is not warming. That makes no sense. From the point of view of atmospheric theory, in fact, the atmosphere has to warm more rapidly than the surface. You remember the early slide that showed that the maximum trend is reached at 10 kilometers. The atmosphere has to warm more rapidly than the surface by about a factor of 2.
Why?
We don't see it.
Why is that?
Why is it that the atmosphere has to rise? Why does the atmospheric temperature have to rise more rapidly than the surface temperature?
Why? Well, to do this, I have to explain a lot about the atmosphere.
All right, let's come back to that later.
It's in the textbooks.
All right.
How is that for an answer? It's in the textbooks on atmospheric physics. It has to do with what is called moist adiabatic adjustment of the lapse rate. The lapse rate measures the rate at which temperature changes with altitude, and in the tropics, this is done by moisture, which in the form of clouds is carried to high altitudes. When the clouds liquefy and release the heat and rain out, the heat remains in the atmosphere, and that's a simple way of looking at it. Moist adiabatic adjustment. Moist adiabatic adjustment of the lapse rate.
All right, we'll Google that later.
We'll do that later. Okay. So the balloon data don't show any rise. The satellite data don't show any rise either. Now, we're looking at the time between 1979 and 1997. This segment here. This segment. Okay, let's just look at the satellite data because they are the most reliable. These are the published satellite data since the beginning of the satellite record, 1979. And you see, between 1979 and 1997, there's hardly any warming. If you analyze it in detail, and I've done this, the warming is essentially zero. The trend is essentially 0 degrees per decade. This large peak happens to be the El Nino of 1998, which was a super El Nino that came along, lasted for 1 year, then it dropped back down again to the normal value. Then there was a sudden jump in temperature. And then in the last 10 years, there has been essentially no upward trend. So no upward trend in the satellite data.
I've seen this graph. If you plot the last couple of months, we are up again at 2009.
What's that?
We are actually up to
I'm actually plotting temperature here.
2010 levels again.
If you go so that goes through May. If we go through what, August? I mean,
Yes.
can that really be important to our discussion?
Yes.
Yes, actually, there is no downward. There is a brief drop, but we actually back at the level that they had at the El Nino, but we don't have El Nino now. So that's kind of. If you drop.
Well, the El Nino has nothing to do with human
It looks very different.
activities. It is a fluctuation and oscillation within the atmosphere-ocean system, and that is why normally we would stop the record before the El Nino or would make some allowance for the El Nino. Some people prefer to simply eliminate that in 1 year, and then you'd have a record which looks roughly like this. Let me jump to the last set of oops.
All right, you're going earlier in the deck. You want to go earlier or later?
Later.
Okay, just down a little to the next arrow.
Yeah.
Up, down, sorry, down a little more.
Yeah.
Here, that arrow.
Oh, that arrow.
I don't think Dr. Singer's used a Macintosh before, so I blame Steve Jobs for this.
Okay, thank you. We've gone too far, so we'll go back up again.
Well, going up you were good at. Yeah, there you go.
Okay.
Oh, I'm sorry. Yeah, you're going up.
Yeah.
Okay.
I'm going to now show what are called proxy data. Proxy data are non-thermometer data that show temperature. This is a business really of the geologists. That's how prehistoric temperatures are measured by geologists. Usually they measure the oxygen 18 isotope or something like that, or they measure the width of tree rings, or they measure the oxygen 18 stalagmites, or they measure deep sea sediments, various devices that geologists have developed to measure prehistoric temperatures. Obviously, it can also be used to measure more recent temperatures. So I will quickly show you some of the view again. Go to slide sorter. I'm more familiar with this. Yeah, we also looked at the sea surface temperature. We looked at the ocean heat content. None of these show. Yeah, let me stop at this point and look at this. Someone asked about data manipulation. To do this, we need to discuss, first of all, the so-called urban heat island effect. We're all familiar with the fact that urban areas are warmer than the countryside. It's an established fact. It has an easy explanation because a lot of energy is generated in urban centers, and therefore urban areas are warmer than the surrounding countryside. You can see it by the fact that snow melts in the city, but will remain in the suburbs. Okay? This is a result from California. I think you just barely see it. It shows the results of 107 weather stations. 29 of those are in areas of more than 1 million people. It shows a strong temperature trend over the last century. You see how temperature increases over the last century? You see here the rise between 1910 and 1940. It's very distinct. A decrease after that, and nothing much more. But this last one here is from counties that have less than 100,000 people. So sparsely settled counties, mostly countryside or farming areas. 27 stations, shows practically no temperature trend, and also a lower temperature. That makes sense, and it's generally accepted. Well, now comes the question, what do these people do that produce the global temperature record? We have 6,000 weather stations in the world. How do they select those that form the basis of the global record? Answer, they choose the best stations. What is best? That's a personal matter. That depends on their judgment. Let me show you the judgment of one of these. Yeah. This is the same 107 stations from California, and this shows the stations that were selected. 6 of them, all showing a large global warming trend. They did not select any that showed a cooling trend or any that showed a trend that was near zero. Now, why would they select stations with a warming trend?
So just a question, who are they?
They thought these were the best stations.
Who is the organization doing the selecting?
This was GIS, NASA, GIS, Hanson's, Jim Hansen and these people. GIS.
And they selected these 6 and they stuck to them?
This is published.
Yeah, and this is the only 6 station they ever looked at?
This happens to be the ones they selected for California. I don't have any data on other selections, but I can discuss this as an example. So let me discuss this as an example. They selected the stations they thought were the best. I don't think that they had any other intentions. They're not committing fraud. They're using their judgment as to what were the best stations. Now, guess, where are the best stations? In airports. Where are the best stations in Africa? They have very few stations there. In airports, because nobody else needs weather stations in any other place. Airports are warming, so that this proves that airports are warming. I'm willing to accept that. That doesn't mean that there's global warming. It has nothing to do with carbon dioxide. It has to do with the fact that air traffic is increasing. I'll come to that in a minute. Air traffic is increasing. Airports are becoming urban centers. My airport in Washington is Dulles. If you know Dulles, or if you knew Dulles 20 years ago, it was in the boondocks. It was way, way out in the country. Now it's become a city. Office buildings around it, traffic going back and forth, more runways added. Obviously, it has been warming. So our suggestion is that much of the reported warming trend in the last 30 years is simply an urban heat island effect due to selection of stations. We don't know the answer to that, and I'm not qualified to do this, but somebody obviously will go over this work. It's painful work, you have to look at 6,000 stations. I don't want to do that. And then discover what happened, how the selection was done. Yes, sir.
And how does this curve look like if you consider all 6,000 stations? I mean, it's global warming. So how does this curve look like if you consider all stations?
I have only basic statistics on that. Let me show you what I have. Oops. This shows the number of weather stations in the world. It started with very little in the year 1900. It increased rapidly after World War II. It reached a peak in 1970. And then they shut down half the stations. Many of the stations shut down were in Siberia. They were shut down after the Soviet Union dissolved. What happened is, without making any judgments, that the sampling population has changed during the last 100 years. Obviously, the way in which the Earth was sampled has changed as the number of stations has changed. Well, if the sampling population changes, you can change the result. For example, if you eliminate all of the mountain stations, the remaining stations will show a warming. If you eliminate all of the Arctic stations, Siberian stations, the remaining stations will show a warming.
Is that because Siberia is getting
So that has
colder?
to be looked into.
So are you saying Siberia is... So what you're saying is if we eliminate stations in cold places...
I'll need somebody who can translate for me.
Okay, I didn't understand the statement, that if you eliminate
Yeah.
weather
Why
stations in
is
Siberia...
is it if you eliminate
Budget
Siberia
reasons.
and you compare it to the
Budget.
data?
They didn't want to spend so much money.
So are we saying Siberia is getting colder?
Well, when you say eliminate Siberia, are you comparing the new data without Siberia to the old data with Siberia?
That was it, yeah.
Okay, that's why.
You change the sampling population,
They don't
you will
remove
change the result.
Siberian points from the old data when they do the comparison.
Yeah. To be fair, you must keep the same distribution of samples throughout. Otherwise, the trends become artificial.
Yeah,
Maybe you better stay here with me.
Okay, yeah. So, as I say, I've tried. I had to stop because I had a day job, but I tried to actually look at some of the data points. There are actually real temperature series available on the internet, going back almost 400 years to some of the earliest direct thermostat records. I mean, the oldest one is in England, but there's some that are almost as old, and I'll try and get more time and publish links to that. But the problem is when you look at the oldest records and you just follow those tend to be in cities that are getting bigger over time. So you're trying to look for old records and for records that have stayed rural, and it's a tricky business. But anyway, we've gone over. I think we're ready for some questions from the Dory and the audience.
Yeah.
Does that sound good?
Yes.
What about the questions that we just had to cancel? Should we do them first?
Would you repeat the question in each case?
I will definitely repeat the question. We should do that for the video anyway. So, Bubble, did you have a question that was on the table?
I had asked, you mentioned that the models take a long time to run. I'm asking about the magnitude of this long.
Yeah, it's long time to run, a day, a week, a month, or a year. If the model takes a long time to run, how long is a long time?
Oh, several weeks.
Several weeks. All right.
Models are very complex. It depends on the length of the run, of course. Yeah.
So, here's a question from the Dory. Can you imagine circumstances or evidence that would cause you to change your mind?
Yes. Evidence.
Okay.
Show me some evidence. In other words, show me a real warming trend in the atmosphere that matches the calculated warming trend from the models. Then I will say that this doesn't prove that the models are correct, but at least it makes it plausible. In other words, it's very difficult to prove the positive. It's easier to show the negative. It's easier to disprove a hypothesis, but that's well known. It only takes one fact to disprove a hypothesis.
So just regards evidence, there was a report in 2009 from the World Meteorological Organization that did suggest that the decade of the 2000s is in fact the warmest decade in modern record. Talking about data manipulation, I did actually notice that most of the graphs you showed us pretty much just stop at the year 2000. And some of the ones you were showing results of the models for the Japanese runs, you kind of highlighted the 0.02 change, but all the other 5 preceding ones under it suggested an increase in plus 0.3 more or less. So on average, they all suggested, I an increase if you average them together, and not an insignificant one. And there was this, I mean, there was a few. It would almost be nice to get them up again, but I would take issue with some of, I mean, you
Well,
had
what's the question?
graphs that were moving up there.
Oh, I guess the question is, did you cherry pick the data and show only the?
Well, I heard the first part of the question,
Okay.
so let me answer that.
How old are your
The WMO
slides?
says that this decade is the warmest decade in the last, 100, 200 years or so. That's correct.
Modern record.
Yeah, that's. What does it mean?
But it's absent from most of your graphs that seem to stop on the year 2000.
Of course it is the warmest. It's been warming for the last 150 years, ever since the end of the Little Ice Age. We know that the climate has natural cycles. I've written a book on this called Unstoppable Global Warming. Every 1,500 years, there's a 1,500-year cycle. And there was a medieval warming, and then when Greenland was warm, and the Vikings settled Greenland and farmed the southern tip of Greenland, and then the Little Ice Age came along, and Europe got very cold, and we have historic records of failed harvests, people starving, and a miserable time. And then it got warm again, starting around 1850. So since 1850, the Earth has been warming naturally.
Why?
There's no question about that.
Oh, okay.
The warming I showed
why
between
hasn't it
1910 and 1940 is real,
Okay.
but
Here,
not produced by human activities.
okay. I've worked with Henrik for a while, so I think I can phrase his question. If the warming is not caused by mankind and our carbon dioxide, what is causing the warming?
That's a very, very good question. This is a question which is hotly debated in the scientific community. It depends on the time scale. If you're asking about what is causing climate change over millions of years,
No, I'm asking about the last 150.
then it is the motion of continents and the building of mountain chains. If you ask what is causing climate change over tens of thousands of years, 100,000 years, then it is changes in the orbit of the Earth with respect to the Sun. The eccentricity of the Earth's orbit is changing, the inclination is changing, and the Earth axis is wobbling. If you ask what is causing climate change on the timescale of decades, and that is the interesting one because that affects humans. We don't really care about millions of years. We're not going to be around that long. So what we ask, what is changing climate on the order of decades? The answer is, or seems to be, I have to be careful.
You want me to
Okay.
wake that up
my
again?
question
Yeah,
is,
wake it up again. I have a
so
slide.
what is causing the Fred Singer cycle of 1,500 years?
So what's caused, for
Unknown to
example,
everyone else?
the climate changes over between 1910 and 1940? The answer there seems to be solar activity. Changes in the output of particle streams and magnetic fields from the sun. We actually have some data suggesting this is so, if I can find it. It's a very striking result. I'd like to show it because it is. Yeah, here it is. Okay, I have to explain it. Now, this is a record from a stalagmite in a cave in Oman. And the time scale here is between 6,000 and 9,000 years ago. This analysis was done by a group in Heidelberg, Germany, published by Neff and his colleagues in Nature in 2001. What they plot here is the record of oxygen 18 in the stalagmite. You know, a stalagmite, you know, has a layer every year. It's like a tree ring. You can read off the date pretty well from the stalagmite record. And here shows oxygen 18, and you see oxygen 18 is a proxy for temperature. That's what geologists use. And over here is the carbon 14 record during the same period. And carbon 14 is a proxy for solar activity. I'll be glad to explain why this is so, but we don't need to know that. Just take my word for it. This record shows a remarkable correlation between carbon 14 and oxygen 18 over a period of 3,000 years. Here's the central portion of the record blown up. You can see it more easily here. Here's carbon 14, here's oxygen 18. Look at the correlation between the two. This is a 400-year period. The correlation is almost year by year. This cannot be an accident. There has to be a real causal connection. There has to be a causal connection between carbon 14, which is solar activity, and terrestrial temperature. And we know which way the correction has to go. It has to go from the sun to the earth, because the terrestrial temperature cannot affect the sun. So it has to be solar activity causing a change in temperature. And that's what this demonstrates. This, to me, is one of the strongest arguments for saying that solar activity changes are the basic cause of climate fluctuations on a decadal scale.
So would you agree that burning stuff isolates that effect?
Agree that burning
Resources on the earth is isolating the effect?
Okay, so the question is burning carbon on the Earth escalating this effect?
That, of course, is the central question, which I've tried to address. And the answer is, we don't see any evidence for this.
Yeah, but
if you can show some evidence for this, I would be happy to consider it.
All right, that brings up this Dory question.
But I just have a quick follow-up question.
Go ahead. Some of the Dories are yours anyway.
Yeah, but regarding I know that. But regarding that the sun affects temperature, I think everyone agrees. But how do you explain that the 3 latest decades have each been breaking the heat record, while the sun activity has been going down?
The sun is very complicated.
No, it's not that complicated.
Well, I think it's complicated.
All right, let's wait for the answer.
I think it's complicated, and I cannot explain every detail.
So you're saying that you don't know?
Oh, I don't know. No.
So you don't know why the sun is getting
I'll wait till
cooler
someone
and we're getting
publishes
hotter?
it.
You don't have an explanation for why?
I don't work in this field. No.
So why are we giving this talk?
Yeah.
Wait. No. Which field do you not work in?
I'm an atmospheric physicist. I don't.
We are not getting hotter.
What did he say?
Oh, that was Ferruccio. We're not getting hotter.
You agree we were getting hotter earlier?
Since 2000.
Well,
we were getting.
Rephrase it. The sun has been extremely quiet during the last couple of years. Yet your graphs don't show a drop in temperature. Why is that?
I think that is probably the answer. I have read that the sun has been extremely quiet during the last few years. We don't know why that is. Even solar physicists don't really know for sure why the sun behaves the way it does. Sometimes the sun is quiet, sometimes it is not.
That's irrelevant.
Yes, why the divergence between the Earth getting warmer and the sun getting cooler? Because that directly contradicts the evidence you're trying to present to us from the year 2001 here.
Oh, there are long-term changes and short-term changes. Yeah.
But there's a discrepancy between your cosmic ray theory and the data on global warming that we've seen for the last decade.
No, I don't think so. I think when you say, why is the Earth getting warmer, I pointed to the fact that there was an increase in temperature between 1910 and 1940. It's like a jump. Then there was another jump in between 1975 and 1980. Then there was another jump between around 2001. So there have been jumps upward, and apparently this is how the temperature curve of the Earth behaves. We don't understand all of the details.
Yes, but you told us that it was related to cosmic rays.
Which is
we're not getting as many cosmic rays over the last decade.
Well, I'm only showing it here in this record. It is clear that solar activity is controlling the temperature in some
But
way.
again, you've cherry-picked a very small period of data that kind of directly contradicts something we've seen over the last decade. So I think you're a little guilty of this manipulation that you're accusing the United Nations scientists of engaging in.
All right. The question is, are you cherry picking? And if you are cherry picking, is that the same kind of data manipulation that you think NASA has been doing?
I'm not cherry picking. I'm merely reporting what has been published.
Okay.
Well,
So
how would those two lines have developed between 1900 and 2011?
Well,
2010? Do we have data for this correlation from the last 100 years?
yeah, that's a fair question. Do we have data for the last 100 years for temperature? We have for cosmic rays.
Here's some.
We also have?
Well, this is not in the stalagmite.
No.
I'm specifically asking for this correlation.
Oh, for this specific.
Carbon-14 is produced by cosmic rays. So carbon-14 is a perfect proxy for cosmic ray intensity. The only source for carbon-14 is cosmic rays. And whenever cosmic rays increase, so does the concentration or the production rate of carbon-14.
Oh, sorry.
Hit the wrong thing. Yeah.
That's all right.
Okay.
So,
Are there any other questions?
all right, I think this is a question from Rupert anyway. What do you make of the strategy championed by Thomas Friedman, proposing that the building of clean power economy confers huge economic benefits?
Oh my God, Thomas Friedman. Yeah. Well,
as well as competitive and environmental ones, while adhering to the precautionary principle.
oh my God. What's the next question?
All right, I've written an article that addresses the precautionary principle. I'll send you a link. But yeah, we'll go to the next question.
The precautionary principle is basically, should you take out insurance against something, you have to assume that warming is bad. Why should warming be bad? There's no obvious reason.
Habitat
We all
loss.
agree that a colder climate is bad. If we also think that a warmer climate is bad, then logically this must be the best climate we've ever had.
So if mankind is responsible for an increase in carbon dioxide in the atmosphere, which is responsible for warming, go ahead and burn as much as we like because we don't care too much about habitat loss or extinction. I actually don't think that we have the moral right to do that.
If you really put me to it, economists have published a book which demonstrates that a warmer climate is economically preferred.
I'd rather not live in a world ruled
But
by
that's not my
economists.
field, so I should not get involved in that. I'm not an economist.
All right, let's move on.
I can tell you that a larger concentration of CO2 is good for agriculture. Everyone agrees on that.
No, that's definitely.
And if you want more food production, we should have more carbon dioxide in the atmosphere.
Biologists don't agree.
All right. I still want to get to the top Dory question. Although, for better or worse, we're moving into ad hominem territory now.
No, I'm just saying that. Yeah, whatever.
I'm used to that. Go ahead.
Okay. You were a strong supporter of other controversies like acid rain, CFC, and ETS lung cancer, which I just learned is environmental tobacco smoke or secondhand smoke. You suggested the science behind them was uncertain, only to later be proven otherwise. How is the CO2 issue different than the others?
I have to be very brief. On acid rain, is anybody here from Germany?
Yes.
Do you remember the Waldsterben? It was a hoax. This has now been pointed out. There were no dead trees in the Black Forest. The Black Forest was not dying. It was all hype. Acid rain is a modest environmental issue. It is an environmental issue. It has been settled mainly by removing the sulfur dioxide from the exhaust gases of fossil fuel burning, mainly coal. But it is not a great calamity. It has been taken care of. What was the next one? CFCs?
CFCs, yes.
CFCs. CFCs will certainly destroy ozone in the stratosphere. No question about that. The issue that I was concerned with is we have natural chlorine in the atmosphere. It's been measured. Has there been a real increase because of human activities? The data didn't show it until after the Montreal Protocol was signed. A year after it was signed, the first paper was published that showed an increase in chlorine, which must be due to human activities, to CFCs. So there's no question about that anymore. Next item.
That's a great example of the efficacy of a precautionary principle, where the world came together, took action on something that affected us all, and actually changed things for the better. Couldn't the same apply to reducing our carbon?
What was that?
Okay. Was the CFC and the Montreal Protocol a wonderful example of the precautionary principle in action?
It was an example of, you might say so, yes. It cost a lot of money, but some people think it's worth it.
Is the ozone hole any smaller now?
No. No. The whole depletion of ozone over the last 30 years has been about 4%, as published by the WMO, which is a very minor effect. A 4% decrease in ozone would also result in an increase in, or should result in an increase in solar ultraviolet on the surface of the Earth, which is what we're concerned about. That increase has not been demonstrated. And that increase would occur if you moved about 100 kilometers to the south towards the equator. So it's not a terribly important issue.
All right. Next one is secondhand smoke.
Secondhand smoke is easy. I'm not a smoker. I don't like tobacco smoke. It bothers me, and I'm glad if there were no secondhand smoke. However, the EPA, our environmental agency, has published that secondhand smoke causes 3,000 lung cancer deaths a year. I've looked at the statistical record. I know something about statistics. It has been doctored. They changed the confidence interval, and they used unreliable results. I'm not the only one who thinks so. Every epidemiologist that I've talked to who know more about such things than I do tells me that the EPA study is not good. And that's all. That doesn't mean that environmental tobacco smoke doesn't cause lung cancer. It could. It just means that their study is not based on sound statistical principles. That's all.
Okay, so it's after 5 o'clock. You're all welcome to stay, but anybody who wants to head out, we won't be offended. And thanks for coming.
And Richard, next to you is going to be I'm here.
Yes. All right. Okay. Let's let the people trickle out, and we'll get back to the questions. But first, we have a special door prize for the German readers among you. We have Dr. Singer's book in German. Doesn't do me any good, although I have an English copy if anybody wants to read. But I can't even
Die
Is that
Natur
what it says?
nicht-menschliche Aktivität bestimmt das Klima.
Oh, nature
Not human activity
rules the climate. All right, my German is improving by leaps and bounds. So, yeah, pick that up here if you like.
I'll take one.
Oh, you'll take one. Oh, yeah, you're welcome to it. Yes, treat it as if it were your own. And,
No.
okay, let's take a live question before we go back to the dory.
I'd like to ask a different kind of question, not a Rupert kind of question. So you presented very convincing arguments here. Some might argue that they are not arguments at all. No, they are arguments. But if a speaker from the other side were here today, they would also present very convincing arguments.
Yes, and I would have a chance
Okay,
to
Fred?
contradict them.
No. So
Okay, yeah, we'll repeat. You want to, and you can listen here, but you want to answer from the microphone so we get on the record. And we'll also repeat the question.
So
I'll do my best anyway. Go ahead.
So the question, of course, is
I didn't
if
ask
we
the
had
question.
people from the other side here, they would present arguments that might also be convincing. And my answer is yes, I wish they were here. Why aren't they here? We would love to debate them because we think the facts are on our side. I've tried to show the facts as they are published. My first point actually used the actual IPCC results on models and data and show the disagreement. If they don't agree with me, then they have to show why the IPCC is wrong.
Okay, and I'll just in an aside, I'll say I've one of the problems I've had with the global warming debate is that the two camps seem mostly to talk among themselves. If you see this on the website, on the web as well, there are warmist sites and there are skeptic sites.
Yeah.
And there are very few sites that actually try and address both sides of the arguments and have, either laymen on either side or scientists on either side talking to one another. In theory, this happens in the journals. An article is published, responses are published, but the time scale on that is very long. And, as we know, some of the journals don't seem completely fair about the submissions.
Yeah, but from the IPCC reports, which are a summary of the journals, right?
Adam, can I add something? No, we have tried, of course, to have a debate.
Yeah, you can, but come introduce yourself.
No. Okay, good. My name is Ferruccio Ferroni. I am the president of one association which is called NIP Swiss. And the non-governmental international panel on climate change, but we have in Switzerland, we have, let's call a session. And of course, we have tried to have a debate between Singer and between, let's call it the other Swiss scientists, which are, the name I give you, it's Stocker, Kluti, and so on. But of course, they decline every direct debate. They say, or they are on vacation, or they are outside of Switzerland, but of course it was not possible to organize a direct debate between the two. And this is also true when for instance, I must tell, when we try to bring some information on newspaper, and also some newspapers that you can assume they are, let's say, more or less neutral, like the NZZ, they will not accept our, let's say, our opinion. This is it's a very difficult message that we try to give through to the public, and it is very, very difficult to give it through.
Okay, sir.
Now, one can choose to believe that global warming is taking place caused by man. But even if one does so, the whole debate seems to center on how we should reduce CO2 emissions. Whereas that, of course, takes resources. We are spending hundreds of billions of whatever currency on that. One could, as for example Björn Lomborg suggests, also just adapt to the change. It's arguably cheaper for a country like Holland, where I'm from, to just make the dikes a bit higher. Spend hundreds of billions of dollars on on trying to reduce CO2 emissions. Now that debate, whether we should actually do something, does not take place. Why do you think that is?
Okay, let me, if we discovered that human CO2 was making the temperature rise, we would have two basic choices. We could try and stop it, or we could try and adapt to it. And the current debate seems all about stopping it and nothing about adapting. Why do you think that is?
That's a very good question. I don't think there's any chance of stopping it, practically. It's a global problem, and as long as the major emitter in the world, which is China, continues to burn coal and other fossil fuels, CO2 is going to rise no matter what the rest of the world does. So it may, if we do, if we.
No. It's if suppose there's no way to stop increases in CO2. The question of whether increases in CO2 affect climate is still open. I think that was what Dr. Singer was saying. Yes.
The question of whether CO2 affects climate is a different issue, and as I've tried to show, it does in principle, but we don't see any evidence for it. So I assume, therefore, that the effect of the increase in CO2 is insignificant, very, very small, too small to be detectable.
All right, we have a new questioner from the back row.
Let's say if your house was on fire, would you rather adapt to the increase in temperature, or would you throw a bucket of water on the source of the flame?
Let's go to our next our next questioner.
Fire, right? It's a problem of the disaster.
All right.
Cool.
All right.
Yeah, it's basically just to sort of add for the comments and then just an observation. I don't have any data, but I think it's very important to separate that doing the moral thing is about pollution, not so much the warming. We can adapt, you know what I mean? Like, adaptation was put forward. But I do think that the moral side, like being eco-friendly, this is the thing about pollution and keeping your environment good. So I think that should be separated when you argue about keeping the air clean or keeping it warm. CO2 is not good for the air for us to breathe and all that, like we've said. But it doesn't necessarily increase the temperature at a rapid rate. You know what I mean? We don't have, like we've got here, one side an argument that's saying it's not doing anything. The other side is saying it is doing something. The argument to change, I think, is obvious. We should change. We should change what we're doing. We're constantly changing in societies in order to have a better ecosystem. Do you know what I mean? So we should separate those two from pollution and from warming. If that makes sense.
Okay, I'm not sure. Let me try and rephrase it. Are you saying that? Okay, first of all, let me go on record myself as favoring morality. I'm sure Dr. Singer would as well.
I favor morality. Sure, okay. Why not?
But okay, but the you're saying that pollution is a priori a bad thing, and if carbon dioxide is a pollutant, shouldn't we try and minimize it, regardless of whether it's making the Earth warmer or not?
That's an unfair question.
Just a comment.
Okay, no, that's good. Why is it unfair?
Because carbon dioxide is not a pollutant.
Okay, there you go.
It is a natural constituent of the atmosphere. There's no evidence that it has any adverse effects. So why should we call it a pollutant?
And all right, one more, and then we'll go to the dory.
Yeah. You seem to have hinted during the presentation.
Can you speak up, please? We don't hear you.
Okay.
Oh, sorry. So you seem to have mentioned a few times during your presentation.
I'll repeat the question.
Louder. Sorry. Is it better? Okay. No.
I don't want to do simultaneous translation, but go ahead and I'll do my best afterwards.
So you seem to have mentioned a few times that there's a lot of, let's say, political motivations behind some scientific discussions or some scientific process. You mentioned like the UN or things like this. And what I wanted to ask you is, what's your view regarding this? I mean, at the same time, you have politics influencing science, obviously, which is the thing you were complaining about. But you also have the other side, right, which is science influence politics, no matter how good or bad the actual science is. So my question is, if you have this notion between science is not good enough sometimes because there's politics, but politics is influenced by science. What's your criteria to decide what is good science or bad science?
Okay,
What's the question?
so you've said that science is sometimes unduly influenced by politics. We know also that sometimes politics is influenced by science. I guess you wouldn't say that's a bad thing, neither would I. But how do you decide what is good science? How do you tell the good science from the bad science? Is that fair?
Well, that's easy. I spent an hour here. I think what I've tried to present here, obviously I'm joking, it's a difficult problem. You can only tell good science from bad science in the longer run. Sometimes scientific controversies are real and cannot be resolved in a matter of days or months or even years. I suspect that this particular controversy will be resolved within this decade. I really do. I think that the evidence against man-made effects on climate is becoming stronger all the time, and that the evidence, I should have put it this way, the evidence that human activities are affecting the climate is absent and will remain absent. I doubt whether any evidence will be put forth that will change our mind on this. But, if it is, we should look at it. In other words, we must be open to the idea that we're mistaken.
Sure.
Yeah.
All right, from the back row.
Do you know the book State of Fear from Michael Crichton?
Michael Crichton.
Yeah, Crichton, yeah.
Michael Crichton wrote a book called State of Fear, yes.
And the theory is that climate change was introduced by politics to control the people.
Okay, so State of Fear was a work of fiction, but it has a lot of factual references in it.
It has to show same references and tries to prove that this is all made up by politics to control the people, to make them pay. It's a business.
I guess, okay, let me phrase the question my own way. If there is some kind of conspiracy among scientists to promote the theory of anthropogenic global warming, what is their motivation, or what do you suspect their motivation is?
I don't really know what motivates people. I suppose there are different motivations for different kind of people. Politicians are generally motivated by the idea of having more influence, more power, more control, becoming elected. Others are influenced by the idea of more money. You have to realize that there's a great deal of money involved in the global warming issue now. There are such things as alternative energies like wind and solar. There's a question of what are sometimes called clean energy, which I think is a misnomer, because no energy is really clean in any sense. It always creates some pollution. But energy is essential. So you have to live with it. The amount of monies involved are huge. They're measured in the hundreds of billions of dollars. Hundreds of billions.
Billions with a B.
Billions with a B, yes.
Okay.
I'm not sure they're up to $1 trillion yet, but they soon will be. The trading system alone that's been contemplated and being practiced in Europe is wasting, I would say, probably tens of billions of euros, maybe 100 billion by now.
For comparison, how big is the oil industry?
Yeah.
I think it's largely, I think it's 2 orders of magnitude larger or so. But
well,
that's my...
It is actually producing energy and all. But
all
right.
This is all based on.
If you're saying there is a conspiracy financed by companies that has yet to take off, there is already no significant solar or anything.
This is all based on 3 points.
I mean, you have yourself been paid by Exxon.
The first point that carbon dioxide is causing global warming. The second, that warming is bad, ipso facto. There's no evidence for that. And third, that we can do something about it.
I
That
think
controls
if you
of
look
carbon
at-
dioxide can really affect the course of climate.
I think probably a pretty large population of the world would disagree with the fact that global warming was not bad. And I know we talk about being able to adapt to it, which is fine if we live in Switzerland, which has a high GDP per head or GDP. But a lot of the world doesn't live in these kind of conditions and doesn't have this much money to throw around. So how would, for example, Bangladesh adapt itself to, I don't know, an increase in temperature or an increase in sea level?
Okay, so for us rich countries, we can adapt. How would a poor country like Bangladesh adapt to increases in temperature or increases in sea level?
Other than by moving here.
Other than by moving to someplace like Switzerland, and maybe we don't have room for them all.
Sea level is a very difficult issue. I have not discussed it here. I have to specialize in this area, but I find that the data are unreliable and conflicting. So I've not published very much on this. It is well known that sea level has risen by 120 meters. I'm talking about global sea level, since the last ice age. 120 meters.
And how long ago was the last ice age?
The peak of 18,000 years.
18,000, okay. 120 meters in 18,000 years.
At different rates.
Okay.
In the last few thousand years, as best as we can tell from coral data, sea level has been rising at the rate of 18 centimeters per century. During the 20th century, sea level rose at the rate of 18 centimeters per century. I think, and this is debatable of course, that no matter what we do, sea level will continue to rise at 18 centimeters per century until the next ice age, and then sea level will drop.
Right.
So no matter what we do, sea level will continue to rise because of the slow melting of ice in the Antarctic that cannot be stopped by anything that we do.
The comment was, countries can adapt to warming.
Okay, so how will the Bangladeshis adapt to warming? We can turn on our air conditioners.
Yes.
Okay, and I'll exercise moderator's privilege. What I would say is that you're not asking the Bangladeshis. First of all, it's that's assuming that we're causing the warming. But even if you did,
no, I'm not. I'm not.
Okay.
I'm just saying that the comment was.
I think.
Okay,
wait. Let me just do one.
But if you already live in a hot country, warming is clearly bad.
But it's not. It's not zero cost on one side. If we restrict carbon use, this is going to make energy much more expensive.
Yes.
And a poor family spends a much higher percentage of their income on energy than we do. So if we make energy more expensive, it'll be more expensive worldwide. It'll be more expensive in Bangladesh. So we're talking about making their lives substantially worse and killing a good number of them because a lot of them live at the margin, possibly for no benefit whatsoever. So
my answer was going to be much shorter.
Yeah.
It's a lot easier to adapt to warmer temperatures than to adapt to poverty. The highest priority is clean water.
I'm sorry. We're talking at each other. So Dr. Singer first. He's the speaker. Then our
Bangladesh, the highest priority is clean water. They're dying of arsenic in groundwater. Is dying of arsenic poisoning. They have other problems. They have cholera. They have many problems because they don't have clean water. It takes energy to produce clean water, and that is the highest priority. I don't think they care about the temperature. Besides, according to the climate models of the Ipcc, the distribution of temperature is such, Ipcc talks about average temperature. When you talk about average temperature, you have to keep in mind that the temperature increase in the tropics is very, very small. Most of this average increase takes place at high latitudes. So the temperatures will increase in Siberia, in Canada, and other places. That's where the increase will take place.
Where the ice will melt.
You know, the word average always hides a lot of information. But if you look at the detailed predictions of the climate models, no matter what you may think about the climate models, the latitude distribution of warming is such that the warming in the tropics is negligible compared to a warming elsewhere.
But the problem with Bangladesh is not the temperature itself, it's actually sea level rise, right? Because there's 200 million people living right on the coast, and basically a meter of sea level rise would flood the whole country. That's the actual problem we're talking about.
Okay, so the potential problem in Bangladesh is sea level. I think you already answered that, but wait. Let's take a break. Our recording is going to stop in 2 minutes, so I think this is a good time to take a break. I don't mind, and I think Dr. Singer doesn't mind staying for a few more minutes, but we'll call a halt now to the official presentation. I hope you'll see it internally and externally in a few days. And thanks everyone for showing up and for staying so long.
I thank you all for coming here and spending a warm afternoon in this room listening to me.